Today, I'm honored to introduce our guest speakers in this webinar. Our first speaker, Mr. Holger Schutt, is the CEO of Akquinet Port Consulting, formerly known as ISL Application. He is working in the field of simulation, specializing in ports and container terminals for the past 30 years. Starting within the IT department of HHLA, the biggest terminal operator in Hamburg, he was responsible for the simulation-based consultancy work of the fully automated container terminal in Hamburg, Altenwerder. In 2010, he took over the professorship at the University of Applied Science, Bremerhaven, and founded the company, Akquinet Port Consulting. With this in-house developed tool, Chesscon, he supports the optimization of terminal processes in all 5 continents. Welcome, Holger, and thank you for accompanying us today. Now let me introduce our second speaker, Oliver Jelsch, the Sales Director at Akquinet Port Consulting. From 1990 to 2001, Oliver was the Manager of Operations at Eurogate and BLG Container Logistics in Bremen, Germany. Thereafter, up to 2012, Oliver was the Director of Sales for the IT Solutions at DataVec, Nuremberg, Germany. And from 2013 to 2019, Oliver was the Managing Director of Cool and Special Transport, a food and logistics forwarding company. Today, Oliver is the Director of Sales and Business Development at Akquinet Port Consulting. Oliver has a master's degree in economics from the University of Hanover in Germany. Welcome, Oliver, and thank you for accompanying us today. As you heard from our colleagues, Akquinet have decades of maritime and logistics experience. And I have the great honor now of introducing TMI Simulation Solutions speakers. Wouter Roos is the Operations Director at TMI Simulation Solutions. Wouter started as an intern in the company in 2006 as an aeronautical engineer specializing in simulation systems architecture, as well as the development of immersive simulators. Wouter was part of a small development team instrumental in creating TMI simulation and e-learning platforms that today is recognized as world-class solutions for aerospace, logistics, maritime, road, and rail transport systems training. In 2010, he was part of the team to prototype and commercialize our interactive driver education system that offers a holistic simulation-based driver training program for learner and professional drivers. In 2015, he was fundamental to develop TMI's Maritime Logistics Chain Simulator, and thereafter the Material Handling Equipment Simulators for training marine and terminal workers. Wouter has an interesting professional tagline, and that is, he's a solution-driven engineer. I'll move over to, thank you, Wouter, for joining us in this webinar. Now let me introduce Brian Stanley. Brian is a facilitator and project manager with over 27 years experience in the maritime and rail terminal operations. Brian has devoted over 20 years to Transnet, South Africa's state-owned port and rail logistics company. He worked as a planner for vessels, yard, rail, and equipment control, and then gradually moved on to being a mentor and coach for planners in the terminal. He also played a key role in the implementation of the current terminal operating system, Navis, that Transnet introduced a few years ago. Brian's professional tagline is that he believes in empowering individuals to excel through knowledge sharing. I think before we begin, I would like to request our audience to share their questions on the chat, as well as to congratulate our guests for an exceptional career path. And I'm sure you're going to take away a few interesting points and comments that they have to make in terms of organizing in terms of applying within your organization. Please make sure to share your contact details through our chat and to share so that we could share with you more information about Akquinet and TMI Simulation Solutions. We will also display our contact details at the end of the webinar to start a conversation. I think it's prudent for me to basically set the foundation on what our guest speakers will be talking about through a few slides. As well as we all know, port evolution has gone through several modes of operation from 1960s, when we had labor-intensive and paper-based operation of today. And nowadays we have logistics hubs integrating with smart cities or ecosystems of operation. Port evolution over time had different management models. Port 1 was managed individually in silos, and it was very labor intensive. Port 2 was managed by processes dedicated by operators in the control tower. Port 3 was managed by automated equipment, trying to optimize processes, whilst humans oversaw process exceptions. And now Port 4 is currently managed by the use of big data and advanced analytics that moderate the many variables in transportation networks with reliability and flexibility. It has been proven through the integration of simulation into port design and operation and training. We are able to reduce costs, shorten development cycles, increase efficiency, performance, and quality of service, as well as to facilitate knowledge management. While simulation evolved in time, its role went from very limited and individual applications. While simulation evolved in time, its role went from very limited and individual applications all the way towards its integration to systems, digital twin-based or parallel simulation that allows simulation to be fused into the process and data mining techniques. The benefits of simulation for port automation is predominantly in concept design and operational optimization, talent development, performance monitoring, scenario planning, and throughput optimization. Simulation 4 shall digitally transform your port. For those of us who are not familiar with digital twins, they are a virtual representation that replicates the features and functions of the real asset. Digital twins are used throughout the asset lifecycle, from the design phase of training and support, all the way to the cradle, all the way to the grave of the equipment. Sorry about that. Today, with advancements in computer-aided engineering models, 3D visualization and sensing technology, and speed and the high-speed communication networks, it is easy to interchange information between the real asset and virtual asset to improve efficiency and operation. I hope I have shared information on the role of simulation 4 and digital twinning. I hope I have shared information on the role simulation 4 and digital twinning plays on your journey towards the Smart Port 4. And now I would like to hand over to Oliver, who shall present Akquinet's role in digitally transforming your port terminal.
So thank you very much again from my side, from the Akquinet Port Consulting. Thank you for giving us the opportunity to present our company here on this fantastic event. The Akquinet Port Consulting is based in Bremerhaven, Germany, and is part of the Akquinet Group. This is the headquarter in Hamburg. The Akquinet Group is a company on shares, and the Akquinet Port Consulting, specializing in simulation and emulation systems in the port industry, in the container port industry, is based in Bremerhaven. So maybe some facts and figures about the Akquinet Group itself. We have about 980 employees in 2021. And we have a planned turnover of about 150 million euros in 2021. So in German terms, it's a medium-sized company. Yes, we did quite well, although, of course, the pandemic took its toll to all of us, but fortunately, we are quite well off. So we have locations and branch offices, of course, all over Germany. And we are doing international projects from Argentina over Canada to Korea and Japan. So we are globally working on our customers and on our solutions. And within the Akquinet Group, which is the most important advantage to our customers, we have many more solutions to offer. It is not just about port consulting. It is also about business processes, industry experts in machine integration and big data items, data analytics and predictive analytics. All these things can be offered to our customers when required and when the requirements are going beyond the pure port topics. So when it comes to ports and terminals, as I pointed out, the Akquinet Port Consulting is doing its utmost to support the customers worldwide, container terminal operators and container terminals itself. We have two managing directors. One is Professor Schütt. You have him here today. The other one is Norbert Klettner. He's also very experienced for some 15 years in terminals and TOS implementation systems. So we have, besides our specialists, of course, we have accumulated a lot of expertise regarding port consultancy services and most specialized in container ports. Akquinet Port Consulting has mainly three columns of business. We are industry experts for solutions of terminal operating systems, so we can do the implementation. We can do the project management for all this, what has to do with the port logistics around industry experts. For IT landscaping, which is the middle column, we are doing IT turnkey solutions and offering predictive analysis and analytics. And this is one of our most important part, as this is very much required by our customers. And of course, our own ChessCon simulation system, which has been developed by ourselves. So it is completely independent from equipment producers. And APC, the Akquinet Port Consulting, is also completely independent from investment companies, from great equipment producers and so on. So we always offer neutral and objective solutions to our customers when it comes to optimization of container terminals and so on. So we are the partner for the entire life cycle, starting with feasibility designs and projects, ending up with operation optimization. So we do port and IT process design if required. We're doing the tender management and, of course, the complete project management. And we are also training, of course, our customers in our ChessCon simulation systems, as ChessCon has been designed from the blueprint onwards to be used by the customer itself. So it's not a complex system to use. We feel that our customers should use our systems and draw the most advantage out of it. And now we come to the ChessCon toolbox itself. I hope you are still tuned to see how the Akquinet Port Consulting is offering the ChessCon modules. And I'm now handing over to Dr. Schütt. He will give you some in-depth analysis about our ChessCon software. Thank you so much.
German for Akquinet. Now, Prof. Holger will explain ChessCon and how does simulation and emulation for terminal operation and designs work. Over to Prof. Holger.
Yes, Divash, thank you very much for the introduction. And thank you for inviting us as the speakers on this side. And also a warm welcome from my side to all participants all over the world. Yes, I will talk about the use of ChessCon simulation and emulation for terminal design on the one hand side and also for terminal operation optimization on the other side. This will be split into 4 parts: the introduction, simulation, the digital twin for terminals, and the conclusions. So the introduction has already done by Oliver. We see here our products that out of the ChessCon family, and you see we use them, as Oliver mentioned, from the first idea over the planning phase, during the startup phase, and hopefully the longest phase of the terminal would be the operational one. All these phases will be supported by simulation tools, and the level of detail is of course going higher and higher the further you go until we come to the digital twin. Divash already mentioned this. Yeah, let's first have a look at the simulation. This started already in the 90s in the port and terminals branch. In other branches it was earlier. The automotive industry, they used it 10 years before that. But we took it up and converted this to the ports and terminals. And if we look at the terminal planning and design, of course the phases are pre-plan and planning. And we do have different tools that I will show you soon. The terminal view is a 3D view of a terminal. And within some hours we can build a whole terminal 3D model to get an impression what you plan. And then the capacity tool, it's something like this. What is terminal's capacity? The capacity is on the one hand side bound by the key side, the length of the key, the number of key cranes, but it depends a lot on the vessel mix that is coming to your terminal. In this capacity tool, we are not looking at the operations like we see here on the right hand side, straddle carrier terminal, or here RTG terminal. We are only looking at the whole yard and looking at the utilization during the discharging and loading of the vessels and bringing these containers to the hinterland via truck or rail. And you see here in this case, the planning of the reefer slots have been a little bit too optimistic. We need more reefer slots. In this case that we see here, we have a utilization of 150%, which is of course not possible. So let me show you this in some studies. The first one is the capacity study. It's about the terminal. And the plan was given to us from a terminal planner. The project was for a terminal operator who want to build this terminal, and he was asking about the capacity in several phases. Phases 1, you see it here, so phase 2 and phase 3. So what will be possible within these phases by using the area? And what we showed, this is already a result of, or a small exception of our result. It shows that the available slots are sufficient. So in the first phase, there are enough slots in the ASC area for both types of containers, the empties and the full. On the right hand side, you see also that there is different, over the time you will have different utilization. Here for the empty yard, you have some utilization up to 95%. But in average, something around 80. This is okay. So typical conclusion would be yes, it's sufficient to handle the anticipated volume. And now we have to check, this is the second sentence. In the 1 week simulation, the block productivity has to be checked to guarantee the operation on the terminal. And of course, we also have some recommendations at the end. In this case, it would be better to have some more slots, which may be used by dangerous containers as well. Because, yeah, there was no overflow, but yeah, should be some more. And now we look at this 1 week of operation to guarantee that the productivity at the key cranes will be achieved. So now we are, in this example, looking at the phase number 2 with some 15 ASC blocks, each 8 rows wide. We have 8 in, 6 out gates, gate lanes. We have, yes, the handshake area at the end of the blocks for the water side. Handshake, the transfer area, and it is quite big with 32 TEU per stack. Well, this is necessary. This is a result of our simulations. We need quite a lot place here. The transportation at the quayside is done by shuttle carriers. And this is how, yes, such a simulation result looks. You don't have to look at the single numbers, at the single figures. So don't mind if you cannot read it. But what we see is in the beginning we have the input data, and the second part we have what was really achieved within these 21 shifts. And you see some red numbers. This means, okay, the expected import numbers were not achieved at this vessel, and so on. But what we see during this 1 week of operation is that we are able to serve all vessels and all trucks that are coming into our terminal within the guaranteed time slots. And some internal moves to bring the containers from the quayside to the landside area. This must not be done, or must not be done during the high peak volume at the quayside. This can be done later on in 1, 2, 3 shifts later. You should get results about the key crane productivity. And one thing that we found out, you see here, we have 15 stacks with 18 rows. The original plan was to build 13 stacks with 9 rows wide. But when we ran this 1 week simulation, we found out that there will be some peak shifts where it is not able to handle the vessels with a productivity guaranteed. So therefore we decided, or together with the client, we decided to change the width from 9 to 8 rows, which means we have more block. And this means we have more cranes, or how they called it, more hooks to handle the water side. And the result here from this is, yes, we achieve the given productivity, or from 30 cycles, 32 moves per hour. So boxes per hour. We have truck and rail operation was handled. The housekeeping was done within the shift, at least with 80%, and the other 12% would be able to be done in the next or the overnext shift. So with this change of the width of the blocks, we were able to guarantee the productivity that the shipping lines were requiring. These tools, this capacity and the simulation tools, they are used by Transnet for 10 years now. They have an internal group, the capacity planning group, and each investment of their rail port, but also of their rail terminals, have to be signed by them, checked by them, and often they use these simulation tools to get exact results. The next step, this also we did with the Transnet, with the Akquinet group, with the Transnet group, was the emulation. This started, the evaluation of this thing started this century. And as Tivash mentioned, I was working for HHLA and we started the fully automated terminal in 2002 after testing it for 1.5 years against a virtual model of the terminal. Yeah, now we are here in the startup and also in the operational phase. So how does it work? You get a model like we see it, you saw it already, or you will see a more detailed one from the Durban terminal. You see all operation above and the terminal operating system down here. And when this container is dropped on the truck, the status is changing and the TOS tells the truck where to bring this container. And he will do the job. When he arrives at the block, the crane will pick up the container. This will be sent to the TOS again, and then the TOS decides what to do next with this truck. So this is a wonderful test bed for your terminal operating system. May also be used for training issues, because you can rerun a shift that was not that good as well. And this is not only for the Sparks, so the Navis N4 system that we have here, you can also connect it to other TOS systems. Oops. And we heard about already the digital twin. In our terms, a digital twin, and Tivash mentioned this already, you need 3 parts. The first part is the physical product. This is your terminal or your port. You need a virtual product. This is the model that we just saw. And for being a digital twin, it's important that you have a connection between both, that the simulated model is all the time on the same state as the real operation. And if you do this, and how to do this, you have the real product, you have the virtual one, and you connect it by listening to all the messages that are exchanged between the TOS and the real world. And therefore you have all state, you have all the time the real state, you know where each single container is, you know the speed of the equipment, you know the location of the equipment. And you can use this as we do it here with the Durban terminal. I think you recognize this because it has this unique Z shape. And here you see we have 3 vessels are served by the key cranes. You see a lot of threads running around here over the terminal, transporting the containers to the block and stack them on the right position. All this is not video only, but it's based on the real data of the terminal. So if we click at any container here, we will see which container it is. We clicked here. You see it's this container. It's a 45-foot container. With all this information, everything that is known in the TOS can be displayed here as well. So you get a view, a visual view of what is happening on your terminal at the moment. But it's you are able to do more, because how to find out where are the containers for this vessel on the upper left. Yeah, you can build a filter in this virtual view and just show the containers that will be loaded to this vessel. And you see in this case, they made a quite fine yard planning, because the most containers are near the berth, but there are some containers on the left-hand side or on the upper right, lower right, which you can transport in between. So this is on the containers, but of course you can do the same with the equipment. So come back to the whole view with all containers, and now we select a straddle carrier. Here's the list of all straddle carriers. We select one. It will be shown here in the middle with a big arrow upon it. And then you get everything what he is doing. You see now he picks up a container and it changes from pick up to move to. And now he moves to this key crane. And you can also select the key crane and you see, oh, the current productivity of this key crane is 22, 23, 25. And what you also would be able, as we filtered the containers, of course, you can also filter the key cranes, showing perhaps the key cranes with a high productivity in green, another one with so the ones that are slightly under expected productivity in orange, and if somebody is really slow, it's red. In this case, it's a real color from the key cranes here, but we can change the colors as we like within our virtual view. You can do this in the real world. And then with this, you get a very fast view, understanding what is happening on your terminal. So some short conclusions already. The simulation is used, for example, by Transnet for securing the terminal planning, greenfields or expansions of existing terminals, or what they did when they had to do some work on their berth. Then they calculated what will this mean to the productivity of the rest berths that they have. And you can have a really detailed analysis about the capacity of the terminal, the best terminal layout, the orientation and size of the blocks. This was an example I showed you. The required fleet side of equipment, how many cranes, how many horizontal transport, how many yard stacking equipment. And the digital twin again shows a more detailed processes and can be used for optimize your planning strategies and optimize them in under laboratory conditions. Not try out what happens with a new parameter set in the real world, but doing this in a laboratory. I told you about training, the operational planning stuff. We will hear about this from the next speakers as well. And with this digital twin, you can also have a look at the predictive maintenance, not waiting until you have a breakdown of a crane and not only use the fixed periods for maintenance, but looking at all this information like air pressure of the tires, fuel or battery level, and all these things to be proactive in the maintenance. So this was the part of the Akquinet. If you want to get in contact with us, do it via TMI or send me directly an email. I'm looking really forward to hearing from you soon. Thank you.
Thank you, Prof. Holger. It has been very interesting to review the features and functions within ChessCon. But I'd like to just share a little story with you, after watching this, thinking about an incident or a situation that I was aware of. A few years back, a port planned an entire terminal, and when they put the terminal together, after the first 3 months of operation, they realized that the entire terminal or the yard layout was completely incorrect, and they caused lots of challenges in terms of the operation. And it then took them 12 months to fix up, repaint, reset up the yard to optimize their efficiency and improve their productivity through that particular terminal. My colleague Brian knows a lot more about it, but yeah, moving on. I would now like to hand over to our colleague Wouter, who will give you a good overview of the Maritime Logistics Supply Chain Simulator, which doesn't just look at the terminal, but it looks at the entire maritime environment and entire maritime logistics supply chain from a training perspective. Over to you, Wouter.
Thank you very much, Deves, and thank you very much, esteemed colleagues from Akquinet, for that nice presentation. So as Deves mentioned, once the terminal planning stage is concluded, we know it's the main focus of the operations team to work towards continuous improvement, and therefore tools that target the performance of the terminal and the interactions of every key role player in the maritime ports is essential. TMI Simulation Solutions Logistics Supply Chain Simulator has a holistic approach to collect, analyze and optimize the different processes happening simultaneously in the port while training role players in a digital virtual environment. So I'd like to do a presentation on this simulator to give you a better idea of what it is and what it can do for your organization and your port. So for this presentation, I'll be showcasing a case study of the Port of Durban that we saw before during Holger's presentation. But please keep in mind that this logistics supply chain simulator can be adapted to any other port or any other logistics environment, not limited to a maritime port, could be an airport, a logistics supply chain, or a land-based hub as well. So what we're looking at now is, you can see it's a little bit blocked, but it's the same keys container terminal that we saw in ChessCon with the typical the Z shape there, and we got all the activities that are happening. We see some pilot boats, we see a helicopter. I will go to more details on them just now, but these are all simulated in our environment. So to start with the overview of the simulator, as I mentioned, it simulates a complete logistics supply chain cycle. What that means, it doesn't just focus at a terminal, but it enables role players from commercial, the marine and the terminal services to work together in the virtual world and to achieve basically a complete cycle, which in this case on the terminal, the container terminal, is a container being imported via vessel and leaving the port, whether it's via rail or a truck, or the other way around when it's exporting a container. So everything that's needed and required to import or export a container is covered by our simulator. As I mentioned, it's applicable to other logistics hubs as well, not just for ports, and it can be fully customized to your specific requirements, your infrastructure, your systems, and your equipment. And it offers training not to people employed in your logistics hub, but also the people you deal with, your clients. On the commercial side, for instance, vessel agents. We'll go into a little bit more detail just now. But they can also be active in this simulator to get a better understanding of what is happening in the port and how what they do influences the process as well. This simulator can have up to 16 active role players at the same time, simultaneously acting in the same virtual world that we just saw. So each action, each role player influences the next role player, which is very important to understand where a certain role player fits inside the logistics supply chain. It can be classroom based, as we can see here in the picture, or it can be cloud based as well, where everybody can train remotely, or certain people can be on one side and the rest of the group on another. All communication is done via phones, emails, or radio, like in real life, but we mimic that in the virtual world. And then all the processes, procedures, and documentation are based on the IMO, International Maritime Organization standards, and can be adapted as well to custom specifications. And same as with ChessCon, we emulate Nevis tools, in this case for the Durban port, to work and operate the simulator, but this can be changed and implemented to custom requirements as well. To start with the simulator, we will start with the commercial planning tools. Some of the active role players here are sellers and buyers, where the process starts because something is being sold off into another country. Then we have vessel agents, clearing and forwarding agents. We got finance and customs. So all of these are individual role players that are active in the simulator. So that's one of those 16. Mostly on the commercial side, it is a lot of templatized documentation, custom documentations, invoices, creating and loading of EDIs, and etc. So if we look at in the simulator on the commercial how that is implemented, we see here the role player needs to put in a packing list, so it needs to know all the details that are required for a packing list or for an invoice, and we provide that as well. So it gives them a better understanding of what data is needed, where does it come from, and why is it important. And also once it's completed, who receives it? Is it the port? Is it, in this case, it will be the clearance and forwarding agent. They need to know what will be on board. The vessel agent will need to know what will be on board of the vessel, etc. Another very important on the commercial would be your vessel arrival notification. And this will basically tell the port when the vessel agent's vessel will be arriving at the port, what will be on the vessel, and that will start all the marine process. So once the vessel arrival notification is received, the marine services and the marine planning and execution tools are used. The role players here are the op center. They are taking care of all the documentation and make sure that it gets to the right people. Another role is the berth planner, who makes sure that there is enough space on the quay side. Then he needs to take into account how long the vessel is staying, what is required. Is it a container vessel? How many cranes are used? So there's also communication with the terminal that's very important to determine those kinds of specifications. And then finally, vessel traffic services. That role player makes sure that all the vessels are being brought into the port, whether it's with pilots, tugboats, or whatever else is required. So that's a very important role. And also there, the planning and the timing of each of these activities is very important. If there's delays somewhere else in the chain, it's important that vessel traffic services knows that and works around that. If we look at some of the activities, in this case, it will be the arrival of a vessel by the vessel traffic services. So we can see here it's selecting the vessel. It has a specific time it is supposed to arrive. And the first thing will be send it to a pilot point where it will wait for the pilot. So we can see at the bottom right, the vessel now is moving in the 3D view. And above that, there is a schematic overview of the port that shows what is happening in bird's eye view. So we can immediately see there's helicopters moving towards the vessel now. And there's also a tugboat that will meet up with the boat later. So we can see the vessels moving. The pilot was brought on board. And the vessel will now move to the channel to meet up with the tugboat. So it's important that vessel traffic services take into account how long will it take for a helicopter to send a pilot, how long will it take for the vessel to get through the channel. So make sure that the tugboats are there, so because we don't want delays of people, tugboats, or pilots waiting on one another. So in the simulator, it's a good tool for the vessel traffic services to get that timing right. And we can see here now the vessel is arriving at the quayside. And the tugboat will be leaving. So once the vessel is arrived at the quayside, that will be obviously lined down to make sure it's secure. And then from there on, the terminal services will take over. But actually, before that happens, there's a lot of planning that terminal services will do before the vessel even arrives. So some of the role players who are doing that planning would be the vessel planner, the yard planner, and the rail planner. These three planners basically plan all the containers that go either on the vessel, on the yard, or on the rail. Then we have three types of equipment controllers as well, and they operate and execute what has been planned. So they make sure that the cranes are operating, that straddles know what to do. And then finally, the last role in terminal planning is the compliance officer, who basically connects everybody together. So if there is a delay, say in a crane, the equipment controller will talk to the compliance officer, and the compliance officer will see what are the implications. If my vessel now staying longer, do I need to talk to marine services? Do I need to talk to the vessel agent to notify them of the delay? Because it's always a knock-on effect with delays in the supply chain. If one thing is late, it will arrive late at the next port, for instance. So these are the kind of things that are very important in the supply chain simulator. And it gives also a good understanding of how that knock-on effect works and who does it influence. So if we look at the execution of the terminal side, we can see here the planning tools. It's Spark. It's actually the same tool that we saw in Chescon, and we can see here the whole yard with all the containers that are currently either physically on the yard or that are planned to be on the yard. So the yard planner creates these plans, and with the, say for instance, there's a vessel coming in, they determine where all the containers will be stacked when it's offloaded from the vessel. So it's obviously very important to take certain things into account, like where is it going, where's the container going, is it leaving by truck, is it leaving by rail, so you want to group all those containers. And as Holger mentioned, it's important, for instance, reefers need to go to the correct stack, otherwise they might not be cooled long enough, and then the client won't be happy as well. So what we see here is the equipment controller is creating a what we call a work queue, which tells the crane what containers to take off the vessel once it has arrived. So it's important that each crane knows exactly what containers are on the vessel, that the crane operator knows what containers need to come off. And then when the straddle picks it up, the straddle needs to know as well, obviously, where in the stack it was planned. So we see here, we can see a nice three-dimensional overview of what's happening in the port. And the vessel is getting offloaded. The containers are being put on the quay side. And we see the straddles picking them up and going into the yard. So one of the nice things with the simulator as well, and especially in the real port, when you're planning, a lot of the planners sit in an office and they can't even see the stacks or the vessels. So our simulator offers a 3D view where the participant can click on anything and it will focus on that part in the 3D. So in this case, we're looking at the cranes offloading, but at the same time, you could be looking at a vessel being brought in, or looking at the straddles or the stack being filled up, or how many trucks are queuing. So it's a good opportunity for people to understand more in real time what's happening as well. And then another nice feature of the simulator is it can run faster than real time as we see at the moment, because the straddles are moving very fast. And this allows a training course to actually run multiple days of simulated days in one day. So if you don't have to wait for the whole vessel to be offloaded. So once the planning is done, it can be sped up, and the people can see what has been planned. And if there were any mistakes, the simulator can be paused, it can be discussed, and it can be rectified as well. So that sums up basically the commercial, the marine, and the terminal that are active in our simulator. And I'd like to conclude with some of the benefits of our logistics supply chain simulator. One of the benefits of the simulator is that it's repeatable training and repeatable scenarios. So you train each group of participants on the same scenario. There's no changes in traffic, there's no changes in weather. So it's not, you can compare each group, you can compare all the performances one by one. It's not like other external factors that are influencing the outcomes. It's also, with the simulator, there's no downtime required on the actual equipment. So the training can be completely separate from the real port. You don't need to have like a crane out of work during the training. There's also, it's a good opportunity to see the outcomes of different strategies. So you can have the same starting point, but you might have a different strategy to achieve something. And you can do it X, Y, Z and see the result of that and compare that maybe with doing it Y, X, Z. So it gives a good comparison between what is the best way to do certain things. And that comes down to you can benchmark your performance measurements, both whether it's crane moves on terminal, whether it's marine moves per hour, all those kinds of things are can be measured in the simulator, and they can be compared with the real performance via the digital twin solutions that we mentioned before. Another good point of the simulator is it's very good to train emergency situations. What do you do when there's a crane breakdown, or even worse, when a ship runs aground, other ships can't enter or leave the port? How do you deal with that? How do you deal with the delays? But also weather conditions, things that happen more often. And finally, one of the great opportunities, especially nowadays with COVID, is the remote training opportunity. People don't need to be physically in the same room or even same country to train together. So it's also, you can learn from other ports, and that's also a great opportunity with the simulator. Yeah.
Thank you, Wouter. You gave us a great overview of the capabilities and benefits of the LSCSIM. But I'd just like to add one more important aspect of the LSCSIM. The LSCSIM can actually integrate with other material handling simulators that would enable live training with crane operators, straddle carrier operators, all basically doing their day-to-day activities in their simulators, connecting to the LSCSIM to to basically see how efficient their operations are. And now I'd like to hand over to our colleague Brian. And Brian, in your experience, while applying the use of the LSCSIM, what would be the impact on throughput optimization and talent development? And how does this translate to port evolution? Brian, over to you.
Thank you, Tivesh. I must say, as listening to the previous speakers, it's amazing how far we've come in the maritime industry with regard to automation and simulation as well. Just to give you some background here, basically marine and dry port terminals are constantly evolving. Over periods of time, you find that there are changes that need to be made in order to stay relevant. So no two ports in the world operate identically. Anyone will tell you this, and you can see it even within the South African context. There's no two ports that operate on the same methods and techniques. So terminal planning and execution themselves are very time-sensitive roles. You find that individuals need to ensure that they meet certain requirements within those specific times, or they start overlapping with other functionality, and this can create major problems as well, as you will see a little bit further on as we go through. Also, you see the industry is constantly looking to improve performance, whether it's from the planning phase to the execution phase, end to end. This is a constant drive that the industry is looking to move towards. Generally, your terminals are measured differently. You get different types of terminals. And when you look at, for example, specific terminals are measured by berth occupancy, others by turnaround time. When you look at liquid bulk terminals, you're looking more in literage and also revenue per ton. And you're looking at container terminals itself, they start looking more towards the technicality of the number of gangs involved, the gross crane hours, or GCH that's known, and also TEUs, which is 20-foot equivalent units. Now, the throughput of container terminals generally is measured by TEUs and is intensively production driven. There's standard operating procedures. There's key performance indexes that need to be checked and ensure that they are met with constantly. High stack occupancy within a terminal can create bottlenecks and also unnecessary handling of containers. This can create, in fact, not only more work, but also increase your maintenance, increase your running costs as well. So vessels generally, you find, spend 40% of their time in port due to the first come, first serve slot allocation system for vessels. You hear terms like outer anchorage, for example. Container vessels or vessels will sit at outer anchorage until a berth becomes available, and I'll touch on this shortly as well. This brings us to digitization and automation as well. Basically, it refers to the ongoing improvement and transformation of business operations, functions, also models and processes, leading to more efficient exchange of information from one to the other. Now, this is key. Whether it's from port to port, for example, port of discharge to port of loading, or whether it's to the next port of call, maybe it's in a different country. Now, with automation, with digitization, when a vessel sails from one port and you close the call in a automated system, what it does is it generates an EDI, electronic data interface, which in turn informs the next port of call that the vessel is now inbound to that port. It gives also related information, for example, seasonal cargo, reefer cargo, sensitive cargo, IMDG, dangerous goods, also over heights, and so on and so on. So it gives a good view in advance because of digitization and how EDI travels instantaneously, information is available. This is key for projection and also for forward planning, like I just mentioned. The important part of this you will notice is that historical data can be used to project future trends of lines or port rotation. Also, patterns are generated, especially seasonal. For example, your reefer containers You can see stack occupancy during that specific time and how it affects the operation within your terminal, and can you accommodate. So I think it's very, very important at this stage how digitization specifically is changing, evolving the current environment within the maritime industry. Some of the main benefits you will find is berth efficiency. Now, berth efficiency is key. If a berth is not available, the vessel will need to stay outside at outer anchorage until it becomes available. It can increase up to 40%, and that is really astronomical. And when you look at reducing of cost in safety, you're looking at incidents and accidents, even fatalities that you can avoid. Also, it optimizes maintenance by up to 51%, and this is proven data that we're looking at as well. With my experience within the South African context, there's always resistance to change when implementing any new products, especially when it comes to automation. This might be caused because of a lack of knowledge or misinformation and so on. I was part of a team that implemented the terminal operating system, which is NAVIS within the South African terminals and inland terminals with the marine facilities as well. And unfortunately, when individuals hear of talk of automation, automated terminals, semi-automated terminals, even auto planning, expert decking, this instills fear within the workforce, and they start looking and considering, does this equate to job losses? Maybe it's also the inability to train unskilled labor. But with the experience that I've had personally, after it's implemented, after the training is done, and when individuals start using the tools, we find it so much easier for them to adapt. Go back to these individuals and they tell you that they find the system more efficient. It's more accurate, more reliable, because they can now start forecasting with more detailed data. Also, when it comes to digitization and automation, it brings synchronized planning in real time. And this allows planners to be proactive, especially during the monitoring phase. If it takes you 8 hours or 10 hours to plan a cargo vessel, you will find during the duration of that working of the vessel, it needs to be monitored to ensure that we're not running into problems, there are no incidents, and so forth. You find strategies can easily be changed because of digitization. Critical solutions can be investigated and without risk or delay in the real-time system itself. So it also provides a realistic view and solutions while exploring different outcomes. Fine-tuning, even tweaking of your yard with expert decking and so forth becomes a little bit easier when you're looking at automated systems. Also, we're looking at, there are some downsides when you look at, for example, specialized technical positions that require experience. It has been recorded that sometimes to get individuals trained, experienced individuals, takes a bit more time. Also, you look at ports, underestimate the importance of acquiring talent with planning and implementation skills. And you find this will speak to HR individuals. It will speak to appointments. You can train an individual or see whether they're capable in a simulation environment to plan a vessel, to plan the yard, to work within certain aspects of the terminal or the marine facility itself. Around 44% of ports and the operators are looking at moving over to digital platforms. And this speaks a lot because there are a lot of emerging ports at the moment and developing countries that are starting to employ this type of strategy. Also, you see added benefits would be, for example, in your berth plan. Now it's in real time. You can forecast more accurately. For predictive maintenance, you find up to 50% of your maintenance breakdowns and so forth can be eliminated due to scheduling maintenance instead of equipment breaking down. So when you look at the automated yard plan, the yard is very complex and very detailed. So when we're looking at the yard planning itself, you find that you are allowed to change strategies on what's called on the fly. while and when it's happening. Also, you find with road and rail infrastructure, you can interchange your equipment between them as well. So the gate, you find often enough within the gate, you find there are peaks, there are highs, and there are also dips, there are lows. And this would be your off-peak times. We can ensure with systems like a truck appointment system that's automated, you can ensure that we flatten the curve to get a more level and a more free-flowing port at your entrances, at your exits, to avoid these bottlenecks and delays within the actual terminal itself. Now, I would like to conclude by saying that digitization and automation is the future of the maritime industry. We're seeing it not only in the first world countries, but in emerging countries and emerging ports as well. And the industry is starting to adopt these ways of working and how it's done and why it's done in that specific way. They're seeing the benefits. It's basically the way forward. So thank you for that, and back to you, Tibesh.
Thank you, Brian, and I think you actually summarized the entire thing very, very well, and you did a pretty good conclusion on your own when you compared, ports that are still in port 3 type of phase, what are their challenges, and how these tools could actually take you to port 4. But I think what's important for me to explain is that the presentations from our experts clearly demonstrated that simulation 4 and digital tools do play a crucial role throughout the life cycle of your smart port, from the planning, performance monitoring to scenario optimization. And tools like ChessCon and LSCSIM enabled you to begin with the identification of root challenges of your port. And thereafter, they provide tools to conceptualize different terminal layouts with detailed models to deploy quayside, yard, rail, intermodal assets to optimize your operations. With analysis from these tools, we will be able to develop infrastructure solutions as well as develop port workers' talent, monitor performance, plan scenario, and optimize throughput. So, one asks you, can these two tools work together? How does TMI's LSCSIM work with ChessCon? And in terms, when you look at it from a consultancy services perspective, when it comes to simulation 4, ChessCon clearly demonstrated their ability to plan and optimize terminals, operations, berth utilization, equipment, right sizing the equipment, as well as the intermodal transport planning, optimization. And also you can develop vessel traffic services and integrate planning and monitoring from port to port. And another very critical element of these sort of tools is you're bringing all these new technologies into your ports, new Wi-Fi connections, lots of data available. What about the people? We need to develop the talent in our ports. And we all know that in the port workers' environment is mostly made up of semi-skilled employees. And the logistics supply chain simulator, together with ChessCon, can really upskill and train your port workers to develop standardized operation procedures and also implement benchmarking techniques to improve the current port status, reduce blockages, and manage your risks in your port environment. And I think I've just been informed by my colleague that we have some questions. So I'd like to go over to those questions very quickly. Okay. So we try and answer all. I see there's about 5 questions here. We'll try and answer all of them, but I'll take the first question that we have. And I think it's a question specifically around ChessCon. And the question is, how readily can ChessCon integrate with an existing TOS system? I think somebody from Akquinet, maybe Professor Holger, would like to take that question, answer that question.
Yes, of course. Yeah, it's a good question because that's really the challenge by connecting simulation tools to the TOS system. On our side, we did it already for some TOS systems, like we mentioned it already, Navis N4. We have a standard interface. The same holds for the CATOS system from TSB from Korea, the system from Tata Consulting Services from India, RBS in Australia, and some other smaller TOS systems. Typically, we like that the the TOS supplier is building the interface to our Chesscon tool. This is because he is used to connect to other equipment, to other subsystems, and we don't have an installation of each TOS system in the world in our house, of course. For this, we prepared an SDK, software development kit. It really defines each message that may be, or this is typically sent between equipment, TOS systems and subsystems. And yes, let me take the example from India. They wanted to cooperate with us. They sent 5 developers to our office, and after 3 months, they sent us something. We thought they had no question in between after the training, but what they sent was wonderful. Yes, they were really working on this interface, and yes, it's in use on several terminals already now. And yeah, that's it from the TOS interface side. So it's possible. It's also possible to include not only the TOS interface, but also include emulators, how we call them, from equipment suppliers, and also subsystems like the equipment control systems, which are organizing the whole fleet of AGVs.
Thanks, Prof. Holger. Oliver, would you like to add to that, or are you fine with the Prof's answer?
I think our experience is that our prepared interfaces to our simulation tools, it's called the SDK, is quite a nice tool. It can be used quite easily by our customers to adapt their TOS to our simulation systems. It works quite well, and our development department did a very good job at that point to give our customers an easy to use opportunity to dock on to most of the TOS systems. Thanks.
Thank you. There's a second question here, and it's also related to Chesscon. And I also when I was paying attention to the presentation, it also sparked some interest in me as well. And one of the things was you ran the optimization on one particular terminal layout. And after about a few iterations, I don't know how many days it was, you got to some sort of optimal layout. The question is, how long would it take to optimize for different terminal layouts with Chesscon? I'm not sure who would like to answer that question. Is it you, Prof, or Oliver?
Yeah, let me try it. A typical project like the one you saw before, where we get a master plan for the terminal, and then we are looking on it. We do our first simulations. Such a project may take some 4 months, but this does not mean that within this 4 months, in the beginning we collect data, and after 4 months we will give you a result. But we do it in an agile way, so we build up the model. This will be 2-3 weeks. And then we start first runs, and with this first results, we come back to the customer, to the client, and discuss the results. What can be done better? We have our ideas out of our experience, but often and this is what Brian mentioned, no terminal is like the other, and the terminal operator typically knows his terminal best. So he has his reason why he's doing the processes, and we discuss it on both sides. Then, yeah, we have the next loop, how we call it, and this may be done 2-3 times, so that after 3 to 4 months, perhaps, you really have a very good result.
Okay, thanks for that. 3 to 4 months to plan your entire port and get it to run efficiently. That's quite impressive, I must say. I've got another question about LSCSIM, and I think that question was basically, with regard to LSCSIM, how long would it take to virtualize an existing port with 3 to 5 terminals? Maybe this is an existing port that somebody knows about and would like to implemented in LSCSIM. I think, Wouter, would you like to take that question?
Yes, of course. It really depends on the type of port that you're looking at. It's how many terminals are there? Is it multidisciplinary? Is it just containers? Is it liquid bulk? Is it passengers? So that whole combination plays an important role. But typically, you're looking between 3 to 6 months, 6 months for a big port with a lot of different terminals. Because remember, it's not just the processes that need to be captured, but it's also the whole 3D world, the virtual environment needs to be accurately representing the real port as well. Different types of vessels, different types of machinery need to be 3D modeled, need to be modeled as well, or simulated. How fast can they go? What are the moves per hour that are possible? So there's a lot of variations that come into play when to say how long it would take, but typically a 3 to 6 month cycle to start off would be a very good estimate, I would say.
Okay, I think that's fairly fast and efficient. When you look at the complexities associated with the port infrastructure, the equipment, and also the types of vessels they have to handle. I think let's go on to there's 2 other questions, but I think I'll just take one for now. And this would be, maybe this question is ideally suited to Brian. Brian, you've worked in the real world and you've also had the opportunity to work with these tools and stuff. So this question is right up your, ideally located to you. Do these tools have an immediate effect in the port environment, or were there lots of resistance and delays in achieving the optimized proposed solutions that were presented from these simulations?
Okay, that's a great question. Thanks for that one. Well, I must say, in the beginning, when you first introduce something like this, there's always resistance. I think especially from the larger ports, they have certain systems in place and there's operating procedures and so on in place. They're a little bit apprehensive as to what's going to happen and how it's going to happen. And I think also the fear of the unknown. Would it interfere with their terminal? And is it going to cause more delays than actually solving problems? So after using the tools, they realize the benefits that it has and the added value that it gives to the terminal. Not only to the terminal itself, but the individuals you find have 100% buy-in thereafter because they realize the availability of data and how more effective the monitoring of the real-time system is made by using such tools. So yes, there are resistance at times, and when the individuals see the performance and what it does and how it interacts, they find that it actually adds value. So you get the buy-in there.
Thank you for that, Brian. I think that was well put, somebody with the experience of working with these tools and in the real environment. I think in the interest of time, I'd just like to ask our colleagues if anybody would like to say anything, add any comments, or something that they would like to just clarify or that they presented earlier. And I'd like to, yeah, if there's somebody, you're more than welcome to say it now.
Yes, just to Brian's response, it's also our experience, but what I really like is that often the operational people like Brian what Brian has been. They are very impressed by the tools, whilst it's hard to convince the management. So it has to come from inside. Yes. So we had a wonderful workshop with the terminal operator with some 15 planning people, and they really were, wow, they really wanted to do something. And unfortunately, the IT director was not taking over these ideas. Perhaps it's also something about, this is my idea and my way to work on the terminal, and now the people have their own ideas and they can test it. And this is a very important thing if you look at the simulation tools, especially if we look at this virtual terminal part. People can learn by themselves. They can play around. They take the shift from yesterday, second shift, and say, oh, this was not good. How to do it better next time? And therefore, yes, I'm really looking forward to our cooperation to yes, convince more and more people. At the moment, we are quite successful with talking to APM terminals, to Adani, to DP World, to ICTSI and others. So yes, let's see what happens.
Thank you, Prof. I'm going to put one of the TMI Solutions guys on the spot and see if they have anything to add, because I suppose they share similar challenges when it comes to convincing senior management on improving their ports environment through simulation.
Mm-hmm. Yeah, no, I fully agree with Prof. Holger as well. Obviously, it's very important to get that buy-in, and we've seen it. I think actually, when you're talking about the planners, it's the middle level that has the buy-in. So I think it's also important not to just, obviously you need the top managers as well, but also on the ground, the people working in the port need to understand and need to be on board of the whole digitalization. It's not just a few planners that's sitting in the offices and using it. It's everybody needs to be on board on it, and they need to understand what's being expected and how can the tools help them. And I think that is where both ChessCon and the Logistics Supply Chain Simulator can play an important role, because it can expose these people as well to the digital tools and get a better understanding on their level as well. So I think that's very important as a role for our tools to play in the port, because without that buy-in, we can have all the nice systems, all the nice theoretical products and everything, but if it's not implemented on the ground level, it doesn't help. It doesn't help us. And I think that's what from our experience in the port as well, we've seen that sometimes, where the ideas are there, but the implementation lags behind.
No, that's typically any sort of new technology introductions in industries. There's always some resistance, but once the early adopters get involved, it then naturally and progressively grows. So guys, in the interest of time, I think let's wrap up, and thank you. I don't know if Brian would like to say something, or Oliver, anything to add to these comments that Prof. Holger and Wouter just made?
Most definitely. I would like to say something as well. You see, leaving all of this aside that we've said, I've been in the game for almost 30 years. And I've seen, from working from a green screen IBM computer-based terminal operating system to where we are now, it is totally mind-blowing. If you told me 15 years ago that we're gonna get to something like this, where a lockdown will prevent us from actually operating in standard procedures that we thought was, basic function like breathing, I will tell you it's impossible. But with tools like what we're seeing now, it's so exciting to see what's going to happen going forward. We are moving in leaps and bounds. And I was just reading up on an article yesterday, and it says that every 2 years, your processing power is doubled with computers. And this just opens up a whole new world within the virtual environment, within digitization, within automation. So this is, to me, as an operations guy, as a planning guy, it's absolutely exciting. I can't wait to see what happens next in the maritime industry.
Oliver, anything to add? That was an exciting one. Good.
I can only underline what has been said now, and I think in the interest of time, I would not like to add something new because everyone has been said, and I'm also looking forward to the new world.
Thank you so much, panelists, and I wish you all well. But yeah, I would like to also say your experience and your presentations really inspired and motivated our audience. And I think technology will always challenge our minds and enable us to develop new tools and new strategies to do business and to optimize our operations. And to our audience, please make sure you stay in touch via email, chat, telephone. We have our contact details displayed on the screen, and we will also be in touch with all those that are subscribed to us so that we can support you in your terminal planning and training services. On behalf of the TMI Simulations team that is behind the camera, and our guest speakers, I'd like to thank everybody who joined us for this webinar series. And I'd also like to give you some background on our next webinar that's coming up next week, Thursday, the 4th of November. It's Series 4, where we will talk about cloud-based marine simulation and training services for pilots, tug masters, seafarers, and VTS operators. Quite an exciting topic, and you'll see how simulation is playing a massive role, and more so, cloud-based simulations to improve training. We will be sharing our guest speakers through our LinkedIn page and our website www.webinar.tmisim.com. So please make sure you register for next week's webinar. And until next time, goodbye and stay safe. Thank you very much. Take care. Bye.